So that was the end of the Eliminator 2 rocket. Now it wasn't a complete failure because the reason we made the Eliminator 2 was to test a new rocket nozzle design for our Super Monkey motor. So before we take a look at the failure of the rocket, let's take a look at the motor. So this Super Monkey motor that we have here uses our third generation nozzle assembly, which has a steel reusable orifice and divergent cone. The convergent is made up of rockite anchoring cement, and that also acts as a heat shield to prevent the metal components from superheating. Now at first glance it looks like it held up very well. Don't see any problems there. So I'm going to go ahead and cut open the motor and we'll take a look at the rockite convergent side. So you can see that we've still got a little bit of rockite anchoring cement still in here around the edge, and all of the rockite that was covering the center bolt here for our orifice opening has been destroyed. That was expected. That typically happens on this style of nozzle. But all we really wanted was just to protect the outer edge from superheating. So it did its job and kept it from overheating and melting the PVC housing. So I'm going to go ahead and take off this retaining nut down on the bottom and drop the nozzle assembly out, and we'll take another look at it. And here's the great part about this particular nozzle and motor design. Once you take that retaining ring out and just give the nozzle assembly a little knock, it just falls right out, and this whole assembly just rinses off and it's reusable. And here we see the bottom side of that rockite and where the washer assembly was sitting into the plastic, and we really don't see any kind of significant melting. I see a little bit of darkening around the plastic just from some minor heat, but nothing compared to the damage that was done on the previous motor. So if we look at this, it also doesn't look like there's a lot of heat discoloration, or really any heat discoloration on the washer, and that's where the heat would have propagated out to the plastic, if at all. It really doesn't seem like it took a tremendous amount of heat, because it just isn't discolored like you would have expected to see it. So that's good. So this will definitely be our nozzle design going forward for the Super Monkey motor. So on to the failure of the rocket itself. So this one's a little bit trickier to figure out, but basically it looks like there was a fin failure. It's interesting to note that all 4 of the fins came tumbling out of the sky in 2 pieces. And I think what happened was that just the speed of the rocket ended up ripping off the tips of the fins. And then once the fins were all damaged and all fairly erratic, then it went a little bit more out of control, and the side forces ended up just ripping the fins off, or the remainder of the fins off of the rocket. So a couple things. First off, the material we're using is an MDF paneling material, and you can see even in a small piece like this, I can bend it and actually snap it fairly easy. So we're going to switch to a thicker material for that. The other problem is, and this was entirely my fault, you can see that there's no slots in this rocket. Just for speed of building this rocket, I chose not to do through fins. I did surface mount fins, which, lesson learnt, no more surface mount fins. Because basically, this cardboard tube has a thin white paper liner that just covers the top of it, just to make it a white tube instead of a gray or a brown tube. And when you're gluing something like this on, all you're really gluing to is that thin paper material on the top. So when we meet up with any kind of side stress, it just rips that paper off, and that's the end of the fin. So lesson learned, no more surface mount fins. So we're going to be back real soon with the Eliminator 3 rocket. We will improve some of these design elements, and hopefully that one goes well. Thanks for watching.